the big things that we want to do in this unit is find the equation of a line. Sometimes you're given a graph, and it says find the equation. Sometimes you're given a couple points, and it says find the equation. Sometimes you're given a slope and a point, or a slope and a y-intercept. So we are going to learn a variety of methods if we're given different kinds of information. And our goal every single time is to find an equation of a line. So very easy, probably the easiest one, is if they tell you the slope and the y-intercept, then it's going to be very easy to find your equation because you can do y equals mx plus b and plug things in right away. So here, they tell us the slope and the y-intercept. If we think of this equation, y equals mx plus b, we already know that for the m, we can write negative 2/3, and for the b, we can write plus 5. So we have found the equation of the line in one form, but these questions also tend to tell you which form they want the answer in. And so this wants the answer in general form, which is ax plus by plus c equals 0 with no fractions, and a being positive. So does our equation have fractions? Yes. We have to get rid of those fractions. How would you get rid of the fraction? Multiply everything by 3. Y times 3, 3y. Here, this is where the fraction was. That fraction will just go away because multiplying by 3 and dividing by 3 cancel each other out. And 5 times 3 plus 15. What do we also need for general form? We need a positive, and we also need it equal to 0. Is the a positive? No, it's a minus 2 in front of the a. So this time, we will move the 2x over to both sides. We will also move the 15 over because we need one side equal to 0. Can you see that when you move the 2x over, now it's positive? The 3y was positive on this side. When I move the 15 over, it becomes negative, and now it's equal to 0. So again, they tell us a slope, so we know m. They tell us a y-intercept, so we know b. This is really easy to start off and write it in slope-intercept form. Then the last part of the question is, oh, it wants it in general form. General form. No fractions. And a is positive. Do we have fractions? No. That's good. Is a already positive? Yes. So we still need to make one side equal to 0. So I will subtract y on both sides. 0 equals 2x minus y minus 7. And Neil, if you really like, when you do that first step, you could have just frozen the screen. Did you guys miss this screen freezing? You're like, probably over holidays you were like, oh, I wish the last day of school would just freeze for a bit. I wouldn't have to go back for another week. I'd like that. That would be good. So you could have written, what I was going to do was write the equal 0 on the right-hand side. Obviously, that won't be possible at this moment. There, oh, do I dare? Wonderful. So now, if the slope and a point is given, you have two ways that you could go about finding the equation. Lots of people in the future will use y equals mx plus b, because when you think of a line, your brain will think of that first, because it's what we will use the most. And chances are, if you use it the most, you remember it the easiest. Okay? But because you're given a point and the slope, it's also pretty obvious that the point slope formula will work, because you have a point and a slope, and there's a formula called the point slope formula. It seems to be obvious that that would work nice. So we're going to look at both of these methods for when you're given a slope and a point. I'm going to start off with the y equals mx plus b method, because that's the one that you're used to the most. So method one, and in fact, we will find out that anytime you want to find an equation of a line, this is the minimum that you need. You need the slope and you need a point. Once you have a slope and a point, you can find the equation of a line. And you can either do that by using y equals mx plus b, or you can use it by freezing the computer. Think it still records while we're frozen?
I don't think so.
You don't think so? So I could say anything about anybody at this moment, perfectly safe putting it on YouTube?
Try it out.
I don't know. Seems
The slope and
the slope is always n. Okay. So using y equals mx plus b, first of all, can you see that you know that m is 2? So that's something you could plug in. And the key thing about an equation of a line is that if a point is on there, remember our relations unit, we learned that you could show things in so many different ways. You could show things by a graph, by an equation, by a table of values, by a set of points. So if this point is on the line, that tells you that that point would show up in a table of values. And that point, if you plugged in 3 for x, you would get -2 for y. Break time. Yeah, only 1 hour into teaching, and I had forgotten that I was frustrated with my computer over the holidays. Completely forgotten that. You probably were. Oh, we're good, okay. Now, if you plug in the point for x, you know that that's what you would get for y. If we plug in the point and the slope, we create an equation where the only thing we don't know is b. And you've solved equations before. Some of you can probably tell me already what b is, but 2 times 3, are you okay that that's 6? Oh, no. And if it's 6, can you tell what b has to be? You could solve equations. What you do to one side, you do to the other.
I have a suggestion.
You have a suggestion?
Close Teams.
Yes.
Previously,
Teams is bad, right?
Ethan was having problems with that. Yeah.
Let's try closing Teams. And then what you do to one side of the equation, you do the other. So if I subtract 6 from both sides, I can show that by doing minus 6, I would get b equals minus 8. And then my equation is, I now know that the slope is 2, b is minus 8. The question asked us to write things in slope-intercept form, so this is already done. Okay? So if you're using y equals mx plus b form, what you do is you plug in the 2 for m because you know that already. And because we know a point, we know that that point makes the equation true, so you can plug in the x for the x, the y for the y, and then you just have to solve for what b is equal to. If you're using the point slope form, what I would suggest doing is above your point, just like we did for distance formula, label the x1 and the y1, and then you just have to write things in. So it'd be y minus, y1 is minus 2, the slope is 2, x minus, x1 is 3, and you get the equation right away. Now, almost always, your question will either ask for general form or slope-intercept form. So the point slope is a good starting point because it's really easy to start it, but now we just need to rearrange. What do we need if we're rearranging? Well, minus negative, what can we simplify? Here I can distribute 2x minus 6. If I want y equals mx plus b, I need the y by itself. Can you see that you need to subtract 2 on both sides? And we get the same equation. They're relatively the same amount of work. Would you agree? About the same amount of work. The point slope form is really intuitive for what to plug in. Because you have to plug in the point, you have to plug in the slope. Y equals mx plus b, a little less intuitive of where you plug things in. But if you know that a point is on the line, that means like a table of values, you can plug in x, you should get that for y. It's using that idea, it's not super hard. Both will work. So try this one on your own. I want you to use both methods. So it wants it in general form, but method 1, and what do we know? We know the slope is negative 3, and we know the point. There's no shortcut that easily gets us to the general form right away. So if you are done the first one already, and you did y equals mx plus b form, you would have got negative 1 equals 15 plus b. You would have subtracted 15 on both sides, and got b is equal to negative 16. So your equation would have been y equals negative 3x minus 16. And of course it wanted it in general form. Do we have fractions? No. But we need to make a positive, so I'm going to add 3x to both sides. Add 16 to both sides. And I would get added 3x, added 3x, added 16, added 16, and there it is in general form. The nice thing about y minus y1 equals mx minus x1, we can just plug things in. So I get y minus negative 1, m, x minus, and whenever you have negative values, add brackets to them, so you would get y plus 1 equals, oh, I forgot to put it in the m. Just do that. The m was minus 3, minus 3x plus 5. I'll distribute. And we don't need to change it to y equals mx plus b form this time. We just need to change it to general form. We have no fractions, which is good. Is the a value or the value in front of x positive? No. So I'm going to need to add 3x to both sides. I'm going to need to add 15 to both sides. And we get the exact same equation. So using both methods, you should have got 3x plus y plus 16 equals 0. I'm still good. My battery is dying on me. On this one? Well, I know that I have y equals mx plus b. I know that the m is minus 3. I solved for b and got b is minus 16. Then I can rewrite y equals mx plus b with the minus 3x. Okay. Negative 3 times negative 5. Good. Minus 1, minus 15, minus 16. Good. Now that you've got b, if you started with this form, right? We solved for b so that you could write in both m and b. Which means you have y equals negative 3x minus 16. That's y equals mx plus b. You now know m and you know b. And now you still have to rearrange the equation. This one is good. Now, if you distribute 3, negative 3 times 5, I will put up the answer for the second one so you can see how you did. And I'll put up the answer for the third one in a bit. And we're done after this. So you see at the end of this next one, it has a worksheet thing and that booklet. That's what you can do for practice tonight. What a good first day back. What is that? Violet, did your bruises go away over Christmas?
Kind of.
Kind of? Oh, that's good. All right, here's the last one. This one I would just use y equals mx plus b form because they tell us the y-intercept and the slope. So that makes it the easiest to use y equals mx plus b.